Start. There we go. All right, so we have F equals ma. Yes? Okay. On all of these things, there's like more to the story than we had before, right? And there's more to it than just that it's a number that we plug in, right? So m, this is mass. This is the most straightforward thing. Mass should be in kilograms, and this is a kilogram right here. Okay? Mass should be in kilograms if it's not converted to kilograms. The only thing I'm going to give you is I'll give you grams, which you should divide by 1,000 to get kilograms. Okay? Always positive, but it's always mass. Okay? Now acceleration is of course in meters per second squared, right? And we could be using a formula like A is delta V over delta T, right? We could use VF as VI plus AT, same exact formula, only it's more formally presented. Okay? We could have VF squared equals VI squared plus 2AX, right? And these are the problems. I think some of these problems you did for today were like that. You might remember this. You had to solve for the acceleration. Solve for this acceleration in there, right? And then the other one was X is VIT plus 1/2 AT squared. You have to solve something first, one of these cute little linear kinematics formulas, and then you can plug it in. And that's the only tricky thing about acceleration, right? Remember also accelerations can be positive or negative. We remember that a little bit? Mass is always positive, and then forces can be positive or negative, right? And this is where we're going to go today, right? Is that this means the net force. Okay, so in this problem right here, you've got 17 newtons to the right, okay? And 9 newtons to the left. I know it's exciting, but here it is, right? And what we want to do is we want to figure out what the acceleration of this thing is. And so what we have to do is do the net force. Well, net force means, what it really means is that it's the vector sum of all the forces. Now, that sounds scary, because vectors were scary, yes? But what do you suppose the vector sum of 17 to the right and 9 to the left is?
I'm gonna go with
8 to the right? Ah, there you go. Okay, so that's all it is. So if you're given, if there's more than one force, what you have to do is find the vector sum of it. And all we're going to do is look at problems in this where they're in one line. So this guy's positive. I'm going to make everything to the right positive. Positive means right. Okay? Right equals positive. Okay? So this and left is negative. So the 9 is negative. The 17 is positive. And then I'm going to use F equals ma, right? But this basically means, what it means is that you have to take all the forces acting on it and add them up. So you're going to go force 1 plus or minus force 2 plus or minus force 3 ... right? That's what we mean. So if there's 15 forces, you're going to add all 15 up. And don't add them stupidly. If they're, if one's to the left, you're going to make it negative, and if it's to the right, it's positive, yeah? Does that make sense? And when you're done with that, you have the net force. So the net force in this case is 8 newtons to the right, correct? Yeah? We just figured this out, right? Okay, so we go 17, positive 17 minus 9, okay, equals 5 times, and it must be that we don't know the acceleration, right? Well, 17 minus 9 is 8. 8 equals 5a, yeah? So a is what? Is it 8/5? What's 8/5? Well, it's 1 3/5, which is that 1.6? Is it? I think it is. Okay, I'm going to go with that. That was my final answer, right? So the acceleration is positive 1.6 meters per second squared, okay? Which means it's accelerating to the right at 1.6 meters per second squared. So if it's not moving, it starts to move to the right and goes faster and faster to the right. What if it's moving to the left and it starts to accelerate to the right? Can you move to the left and accelerate right? Can you move to the left and accelerate right? Yeah, you can. I'm going to demonstrate it. You'll see me. I am moving to the left, aren't I? And now I'm going to accelerate to the right. What did I do? Slowed down and stopped. Okay, that's all that means. Okay, so the crazy thing about these problems is that we can only discern the direction of the acceleration. We can't determine the direction it's moving. We got to know a bit more about it, right? We got to know its initial velocity or something like that, right? But we do know that this thing is accelerating to the right. Okay? Are we good on that? So that's one kind of net force problem, is where you've got these forces and you've got to draw a picture, decide which way is positive, set all the positive forces minus the negative forces as MA, right? The other kind, and I think it's a little bit harder, is when you've got an unknown acceleration or an unknown force, right? So here's an example where there's a force that we don't know, okay? And it could be that the 450 newtons is the only force, but I don't think so. So here's this object, right? This is what, 35 kilograms? Okay, there's 450 newtons of force to the right, and I'm going to make to the right positive. Okay, it's accelerating which way? To the right at 9 meters per second squared. Okay, and I'm drawing this off here, and acceleration is not a force, so I'm not attaching it to this thing. Because this is to the right, I'm going to make the acceleration positive. Okay, it's a positive acceleration. Now, were it accelerating to the left, and could it accelerate to the left with a 450 Newton force to the right? Well, no, not if that's the only force acting on it, but if there's a much larger force acting to the left, couldn't it accelerate to the left with this force acting on it? Yes? If it was overpowered by another force? Yes? Okay? This is hard to understand. Pay attention. Okay, so here's the notion, right? We've got this thing, it's accelerating, and then there's some unknown force, right? So this one is, these are the hard ones, I think, to set up, right? But they're not really that hard. Now, I know, by the way, that this force will be a negative force. Here's how I know. If there were no other force, we just go F equals ma, so 450 is 35a, and the acceleration would be bigger than 10, wouldn't it be? 450 divided by 35 is a number bigger than 10, but it's only accelerating at 9, so therefore there must be some force making it not accelerate so fast, and it must be acting to the left. Now, did that make sense to you? Yes. It doesn't have to make sense to you, because this thing is it's like one of those dowsing sticks. It's just going to lead you to the water. Okay? It's going to work, only it's better because it's like math, right? So here's what I do is I just set this thing up. Everything to the right is positive. So this force is positive. This acceleration is positive because it's to the right. And then we just set this thing up. We've got unknown force. Always make unknown forces positive. Don't guess that they're negative, because then it gets confusing. If you guess it's negative and it's really positive, then it's going to be negative, negative. Do you understand that? No, not really. That's hard. Okay, so always just guess unknown forces, even if you know they're negative. Guess that they're positive, right? And then go, okay, F plus 450. Those are all the forces. There's an unknown force probably. Right? If there's not, by the way, it'll solve to 0, right? And then that equals 35 times positive 9. Okay? So all of these things, every force, unknown forces, you always make positive, right? All of these guys here, every other one, is it positive or is it negative, right? You've got to look through, decide, is it positive, is it negative? Is it positive, is it negative? For the acceleration, you also have to decide, is it positive or negative, right? Don't just go, okay, it's positive or it's negative, right? Because you'll get it wrong. That's what I'm trying to do is give you cases where you've got to look through. So it's a little bit more complicated than just plugging numbers in and just chugging, right? You've got to think it through. You've got to decide which way the forces are, right? Now we can solve this. This is not so difficult. So schwer ist es nicht. Okay, so 35 times 9. 315. You just said something not very nice. I'm just kidding. Okay, so F plus 450 equals 315. It's going to be negative, isn't it? So what's our next step? Yeah, I'm going to subtract the 450 minus 450. I'm getting the kids that, like, you guys, some of you guys survived the CPM debacle of, like, we're going to do CPM and then we're not, and right? So some people are just like subtracting when they should divide and stuff like that. So we'll learn it. It's just algebra. It's just good algebra, kids, right? So in this case, to get rid of this, since it's not multiplied, you want to subtract. You don't want to divide, right? So 315 minus 450. Didn't you guys, some of you guys, weren't you in that whole CPM thing, and the parents didn't like it, and some parents liked it, and some kids liked it, and some kids didn't like it, and